Hello, it's David from David Savery Electrical, and today we're doing something very exciting. We're installing a Tesla Chargepoint. Those of you who have been watching our crap may recognise this installation. This is one that we were looking at recently, working with our builder Sam Smith, money out my mind, who's got this dual RCD board in where we've had to change out the RCDs because the 63 amp ones in there were looking a bit toasty. We're not planning on hanging the charger off here. We're going to be installing a secondary board, which Nigel is actually playing with at the moment. And it's one of those Luden boards I looked at in my cocked up SPD installation video. Let's have a close look at that, Nigel, because this one has been modified. This isn't quite as it was on the shelf. You can see we've taken out the main switch and replaced it with a Type A RCD. We've also added an additional breaker to drive the car charger. Now let's have a little chat about this, shall we, Nigel? Would you like to model that while I talk shit? A couple of things to say about this. Why a Type A and not a Type AC? Because we don't like to fit Type ACs anymore. We put in Type A's where possible. Look at the E5 group channel for more information on why Type ACs aren't great on installations with a lot of DC. Why not a Type B, Nigel?
Sorry?
Why not a Type B?
Well, we're looking at the breaker.
The RCD.
Oh, the RCD. I don't know.
I know people are going to be in the comments going, why have you fitted a Type A, not a Type B? I'll tell you why not a Type B, because if you can find one that's under 500 quid, good luck to you. They're just not very readily available and they're not very cheap. Another thing to say about this RCD, notice that the terminals are labelled, so the light on this camera is very offset, isn't it? Table labelled as 1, 2, 3, 4, not as line and neutral. I've checked the manual for this RCD and it says that the input can be on the lower side, it can be on the upper side, and you can switch it between line and neutral, and either way it's completely polarity insensitive. So you have the option there of using that in whatever way you see fit. Some equipment obviously is labelled line and neutral, this is not, and the manual does specifically say you can connect that any way you want. But I put on a slightly larger buzz bar because we've got an extra breaker in there. This is the breaker that came with it to drive the surge protected device, because we're also going to be leaving the surge protected device in there to help to surge protect the installation while we're about it, and why not, because it's such a low cost enclosure. So we've added an extra MCB for the charger, and the surge protector will be on the MCB here. We are going to cut that cable down. Obviously,
yeah, not in yet, is it? We
want to keep our connection to the surge protector as short as possible. It is going in parallel to the installation, so we want our connection to be within half a metre ideally. If we can cut down, we've already got about 20 centimetres lost in the board on the line and neutral, just coming off the overcurrent protected device and the earth bar, so we want to keep them to a minimum. If we can cut that down even further, that line, and just bang it into the MCB next door, then it just gives us a few extra centimetres to play with. But we will be effectively teeing off the feed to this board to give us a feed to that board, and that tee off point will be less than half a metre once all the cabling has been taken into account, because the regulation states that when you start counting your half metre position, it's from the point where you connect the SPD. It's the connection point to the SPD. It's not the fact that the tails are coming all the way from the board across and out into the meter point out there. So we're going to move that fuse for the intruder alarm above the intruder alarm. We're going to be cutting open this wall to sight this box in. Okay, as we showed in our video previously with Sam Smith, money on my mind, we have two armoured cables here that have been left in the board. 3-core 2.5 mil, and it turns out it's not two armoured cables, it's one loop. It goes outside, loops, comes back. We think that was put in for garden lighting or something, but now they want to use it for car charging. The problem with that is we'd rather have a 6 mil cable on a 40 amp breaker to provide 32 amps charging. We can't put a 40 amp breaker onto these cables. We can combine them both, so we've got a combined cross-sectional area of 5 mil, but I wouldn't want to run 5 mil off a 40 amp breaker, so we're going to limit it here to 32 amps, which is why we've got a 32 amp in the Luden board. And then we're going to set the Tesla charger to run at 24 amps, yes, rather than the maximum that it can deliver, which I believe is 32. That's self-settable. I suppose we better start by getting that earth rod in.
I think we'd better get the rod in.
Have you got the rod, Marsh, or is it just the way your trousers rock up?
I was going to stick it down my pants, but I got a belt on, so you can't film me ass today.
Oh, that's a shame. Before I bumble on with the on-site speech, perhaps it's best to have a quick illustration on how we intend to install this mother, and with the aid of 21st century special effects technology, no less. Yeah, how about this for skills? Picture in picture on the last video, and a floating bust in this one. That's pretty impressive, don't you think? What we have here is a pretty basic setup. We have the 100 amp intake, a meter, the existing consumer unit and an existing loop of armoured cable going outside. There is an isolator after the meter, but I haven't shown it in this picture. You'll see it later when we look in the meter box. And there is also a secondary small CU hanging off the stack enclosure, as it turns out. But back to the Tesla charger, and there's not an awful lot of information about UK installations. We need to be mindful of issues such as earthing and maximum demand, which may be of lesser concern in other countries who perhaps enjoy three-phase more commonly, who aren't subject to the likes of regulation 722.411.4.1, which requires us to put in an earth rod as we're prevented from using the PME earthing of this installation as the protective earth for the car charger. Unless there's something different about these Tesla wall connectors that I just don't know about. The technical manual doesn't mention anything about earth rods, but then it isn't specifically written for the UK and has the get out clause that local regulations apply depending on where you're installing it. But I expect everyone out there is an expert on Tesla Chargepoint installations, so I look forward to reading in the comments on how I've done this one all wrong. So yes, this is a PME installation, and as shown, the existing CU is already too heavily loaded to accommodate a car charger, and the RCDs in the consumer unit are also unsuitable for the task as they're type AC, and we require either a type B or a type A according to the Tesla documentation, but that's what we would have fitted these days anyway. What I propose to do then is to split the tails to the main board using a Henley block and shoehorn in our modified Luden enclosure with SPD, overcurrent protection and 80 amp type A RCD. The existing 2.5mm armoured cable will split in two and pair together to give a cabling with an overall CSA of 5mm squared. We'd prefer to run this thing from a 40 amp breaker so that it can deliver 32 amps to the vehicle, but 40 amps would be too high as an overprotective device for a cable with effectively 5mm squared of cross-sectional area. So we're going to limit the breaker in the Luden board to 32 amps and set the charger to operate at 25 amps as the charge current is definable within this thing. This does mean that the charge time is longer, but there's another advantage to limiting the charge current that I'll get onto shortly. Why are we using this existing armoured cable if it's a bit weedy for the job? Well, because it's there, and replacing it with a larger cable is no longer an option. This cable was installed for future expansion when the house was refurbished a few years ago, and it's no longer possible to replace it while keeping it hidden within the fabric of the building. The homeowner made inquiries with Chargepoint installers, but they all wanted to keep the job simple, and that meant not using the existing SWA and running a new fatter cable around the outside of the building for about 30 metres back to the meter cabinet, where they would then install a small subboard spliced into the installation. It would have been an eyesore as it snakes around the front of the house, so although the way we're doing it will take longer, cost more and deliver less power, there will be very little exterior utilitarian components on the outside of this pretty house to make the homeowner feel small. Also, the Tesla wall chargers aren't under the OLEV scheme, so the homeowner can't get a grant to help cover the installation costs. Therefore, if he must pay someone to come out and fit it, then he may as well fork out a little extra to have a neat looking job. Limiting the charge current is also advantageous for our maximum demand. We can't calculate the demand of this installation on paper in the way the on-site guide shows, as, among other things, there are 7 lighting and 7 socket circuits. So if we went by the maximum demand calculations, it will always come out way much higher than the 100 amp single phase service we have to play with. There are a lot of circuits in this house, but they're not all being battered by heavy loading. Having looked at what's actually in use, we think the demand is nearer 70 amps worst case, so by limiting the Tesla charger to an operating current of 25 amps, we should remain under the limit of what the service was designed to deliver. And that's important both for the integrity of the installation and also because we have to notify it afterwards to the district network operator, who will ask on their form what the existing demand is. To help back that up, we have a QTEC 2040 clamp meter, which we leave on site over a 24-hour period with the max setting set to on to see if there are any surprises as the family go about living their lives. Several readings may be required over a number of days, and winter demands are obviously different to those of the summer, but it can be a handy way to check that the demand measured on over any given period is going to be lower than anticipated. Back to the physical install then. The external armoured cable will terminate onto a whisker box below the charger. The line and neutral will then be sent up 6mm singles via PVC conduit into the wall charger. a 6mm earth wire will come from the wall charger and pass down the conduit out of the whisker box and to an earth rod, as regulation 722.411.4.1 says we can't use the PME earthing. This earth rod will also connect to the SWA sheath and a dedicated earth core in each armoured cable. Personally, I still don't understand the need for TTing EV charge points. The wall connector itself has an insulated housing, no juice is sent down the cable unless it's plugged in and the car commands it, the metal body of the car is on the DC ground of the accessory battery, and it wouldn't rise to 230 volts even if the pen conductor failed. Or not that I can see, so I don't understand the need for it myself, but I must be missing something, and I'm happy to be put right by commenters cleverer than I. Back at the consumer unit end, the two armoured cables will terminate onto another whisker box, but the earthing connection back to the rod will end here. We don't want to take that back to the earth bar at the consumer unit itself, as a failure of the pen conductor could see our earth spike suddenly acting as a neutral sink. Nor do we want our TT'd bits to be touch accessible with the parts of the installation earthed by PME, as they may be at a different potential. So we'll take an RA reading from here to ensure the rod and the SWA are all within parameters, then we'll close up the whisker box and stuff it into the void behind the consumer unit where it won't be possible to access it again without tools. There's nothing to maintain in the whisker box where the SWAs terminate, so no need for it to remain accessible for inspection. The reason we've earthed the SWA cables in this way is to keep the PME earth inside the building so that it isn't exported to the outside, and to remove any accidental simultaneous touch access between both earthing systems. Anyone poking around in the external whisker box or accidentally piercing the external armoured cables will be standing on the same physical earth that the rod is shoved into. There are also no other electrical or bonded services from the PME installation within touch distance of the wall point position. The line and neutral wires of the SWA cables enter the Luden board via a short length of flex conduit from the internal whisker box, where they then terminate. As at the charge point end, I'll be splicing them together with 6mm singles using Vargo connectors. For the surge protection, which we're only putting in because we had this Luden board and figured it wouldn't hurt, we'll be routing the main protective earth via this board to put in an intermediate earth terminal, as I showed in my last video. So that's the installation plan. Apologies for this ill thought out visual aid, by the way. I've done it all far too small and squashed it onto just one side of the screen. I mean, there's more effort here than with John Ward's cow in his recent earth rod video, but I was kind of expecting to show the car on the right here, except it seems to be missing. Don't worry folks, I'm alright really. It was just more of my spiffing special effects, or camera tricks if you will. I hope I didn't worry you too much there. Let's get back to site on the tool work. Right, well this is where we're going to site the thing. I was just doing some checking with the utility finder, which is I have about as much faith in as a stud finder. He's picking up the SWA cables out of there, which we know are crossing that point. We think we're okay to rod down there, to stick our earth rod down, but we'll see if we hit anything we shouldn't. Personally, I'd have preferred it over on this wall. The client wanted it on the side wall there, but that puts it quite close to this earth light fitting, and of course we've got mismatching earths here because we're on a PME or TNCS installation here. And we're going to be putting an earth rod on this, so by getting it around the corner on the other side of the drain pipe we should have it out of touching distance of anything else. Sounds like Pac-Man, that thing. It's Sam Smith.
Hello.
Money on my mind.
Yeah, that could catch on. Let's hope not.
Hang on, bloody hell. Nigel's just going to, you're very close to those armoured there.
I'm not through the armour.
No, I'm just checking. Nigel's using his Makita to slam this into the ground. We're not quite sure how successful it's going to be, but we are hopefully confident that we're not going to hit anything. I'm just going to stand back in case there's a gas main under there.
Well, it's firm.
Yeah.
It's moving, but very slowly.
Ain't doing shit. There's no way you're going to get that all the way down there. There's a good ½ metre left there. If you wiggle it around too much, it's a waste of time anyway, because you're going to have shit contact.
Pull the bugger back out.
Don't strain your poo strings. drive it down.
A bit further, yeah?
No, that's probably enough because we need to be able to get access to the top. Fortunately, we've got the drain plans here as well as the utility finder, so we know we're fairly safe to put that there. But the ground feels pretty crappy, doesn't it?
It does. It feels like there's hollow sections. And
didn't feel tight going in, so I'm not convinced we're going to get a great reading off that. We'll just have to suck it and see. But that's where it's going to have to be. They provide us with a cardboard template for mounting. Nigel's just ensuring that the screw holes we're using are going into brick and not mortar. And he's using his wanky little spirit level to...
Well, as they give me a wanky little template.
Do you want a man's spirit level, Nigel?
No, it's the size that matters.
Fucking is. You've just been lied to by too many women, mate. And they feel sorry for you. Minimum height from the ground is 122 centimetres apparently, because again the homeowner did want it on the short stubby wall over there, and we had to say, well, sorry, but the manufacturer's instructions say no. Right, we've got, it comes with 2 mounting brackets. Let's have a look at those while Nigel does a bit of drilling. We've got the low profile bracket, which allows you to stick it onto the wall with a minimum profile coming off it. And is okay for bottom entry. We've just put a gland on here because we will be using bottom entry. If you're using top entry or rear entry, then you have this secondary bracket, which would add rather significantly to the profile of the thing once on, but gives you some additional connection options. So we won't be using that bit. Doing a proper drill.
What do you mean proper drill?
Just looked like hard work, that.
That's better than your goddamn green piece of crap.
My Roby would have been through that in a moment. What is it they say about the best laid plans of mice and men? So the meter's on the other side of there, and I thought the tails came through there, up the cavity to the board, because if you look in that board, they start going down. I've had that alarm spur off, and taking a peek behind there on those meter tails, ain't going up, so they must be coming from above, which is a pain in the arse because I want to break into them, and I want to break into them in such a way that I can effectively install this SPD, and the only way I can see of doing it is to have this moving board above the other boards, which puts it much higher than I would like it to be. I mean, it's in line in effect with what's already there, but obviously for control gear you want to mount it lower down the walls these days for access by people with mobility issues. But it's just this space though, isn't it? What can I do? I've got nothing to work with here. If I bring it down to that level there, I'll have to exceed the connection point to the SPD. Very difficult. I think I'm going to have to go up there whether I like it or not. An exploratory hole has been put in. Let's get the light on. See a whole bunch of cables coming down in this cavity, and the tail ones are up there, so they come from above, as does the earthing, which means I'm going to have to cut my Luden board up there. What a pain in the arse. But you know, sometimes you're out on site and you just have to work with what you're presented with when you're retrofitting stuff in. It is what it is. Excuse the noise of the vacuum cleaner in the background. Right, what we've got here, I'm going to try and extend these 2 armours up. I'm terminating them onto this small whisker box here, one of these half-size whisker boxes. So that's where our TT earthing will come in, and once that's enclosed off, it won't be touch accessible inside, nor does it need to be accessible for maintenance because there'll be no connectors in here. The wires coming from the armours are going to go in some flex conduit at the back here to where the Luden board is. Also, for doing that little earth nut screw up, thank goodness for my Armeg right angle screwdriver set here, which I picked up at Alex. That's a rather nifty thing and just got me out of trouble there today. Before we close all this up and lose it in there where it can live happily, we want to get our RA reading. So I'm going to clamp onto here because the only earthing in here is coming from the rod outside. The SWA armour is earthed, the black cores within the armour are earthed. It's all joined together there and it's not going back to the board. So once that's closed up and gone, we won't be able to take another reading. So let's connect our probe to our incoming terminal and run a test, and we want something below 200 ohms, ideally as low as possible. It's not far off, is it? I mean, technically it could be as high as 1667 ohms, because a touch voltage of 50 volts divided by a tripping current of 30 milliamps is 1667 ohms. But the regs say that it ought to be below 200. Our standards say it ought to be below 100 really, and we like to see it as low as possible, so I suspect on this site we may have to stick in a second rod. Not immediately. We can run with that for the moment. Nige scrabbling around in the dirt like the vagrant he is. You're not going to find tab ends down there, you know, Nige.
Tab ends, but yeah. Lots of tabs.
That's the beast on the wall. I had to put a bit of a kick in the conduit coming down. We haven't got our wires going up there yet, have we? There was a miscommunication between Nigel and myself, because I had in mind the line of neutral just going straight up there from the SWA, but we've got cut them off at the box, so we'll have to put some Vargos on to extend them up with some 6mm. Because we've got two 2.5s coming out of these SWAs, the two greys, the two browns, we've got to join them together and extend them up via 6mm, a couple of 6mm singles into the beast. We're also going to run a 6mm earth from there down to the earth bar, and it's a 16mm earth going to the earth rod. Okay, let's see, hammer's terminated. I've opened that up a bit so we can lose that in there now, and then coming off there is our flex conduit with our SWA wires coming out of the end. Oh, I've got so much kit outside this room today. I've had to get the barriers off the van just to stop anyone coming around that corner from tripping over my toolbox and stuff. So don't let it be said that I don't always think of health and safety. I have to bob a hole in the back of my Luden box for my flex conduit to come into the back of this thing with, but let's not mess about here. We're going for the Armeg Accelerate, which is just about the best way to smash a hole into steel. Feel like a knife through butter with this thing, especially as it's brand spanking new. Safety hat and goggles on. No messing about. Don't you love it? Good old Armeg. Breaking into the main tails here, so I need to isolate this son of a bitch. These grub screw things are about the only thing I ever use for safe isolation. Fit pretty much everything. Obviously, someone could wrench that off, but you can't protect against stupid, can you? Of course, that was the main switch out there, so we should be good to go, but I'm still going to test my voltage indicator on my proving unit, verify that indeed my TIS 859 is working okay. Let's check line to neutral, dead, line to earth, dead, neutral earth, dead, and just to make sure Yep, my 859 is still okay, so safe for me to play with these tails. I might just survive today's work. So I don't know how I didn't spot this before, but I was just about to undo the main tails, and what the fuck is this? There's a fucking 6mm on the incoming side, going off to a final circuit somewhere. I mean, oh, I don't know how I didn't notice that before, or what the fuck's going on there. But we'll have to find out what that is and get a shot of it. We're done, aren't we, Nigel?
We are done.
Jolly good. Well, kind of anyway. Let's just angle this down a bit, because our initial plan was to put it next to the board here, next to the intruder alarm. We're going to have to put a dual Patras dryline box in there to sit that on, and to put a blank next to it. So we had to widen it up to shove our armoured inside. So our boards had to go higher than we would have liked, which is unfortunate. But we are ready to power back up. A couple of things to quickly say. That 6mm that was coming directly off the main switch turned out to be the fire suppressant board. So that's ironic, isn't it? Probably alright actually, because it was just coming from there going into here. And then you've got protected devices, so unless there's a short circuit at the main switch, it's not going to cause too much bother. Even so, still don't like it much, and I have changed it for the 25mm flex tails while I'm here, because I can. The tails we've broken into, again, we have to think about how on earth we were going to do that here. We didn't want to leave handy blocks or connectors concealed behind here that no one could get access to, so we've actually cut out a dry line box up there. Let's see if we can zoom in a little bit. Oh. This is high tech, isn't it? Really wrong way. We cut out a dry line box up there, and you can see we've got two handy blocks sitting inside that, which we shall cover over with a blank plate. So although you can't see the tails going in top and bottom on there, at least the connections remain accessible, so if anyone ever needs to inspect them, they can inspect them. And also coming off those handy blocks are our tails to our Luden board, which is parallel to the installation and will provide our A-type RCD for car charging with overcurrent protection, and also the SPD. And unlike my last SPD video where I left the connection too long between the connection point and the SPD device by 10 or 15 centimeters or so, this time we're coming in from the connection point above into here, and then with this rejig board we're coming in a short tail out to here, and then the earth to here, this now being the intermediate earthing point. The main PE comes in here, and DB1's earth comes off there to here. So this whole installation for the surge protection is under 1/2 metre. Whoop-de-fucking-do. What a pain in the arse it is to get that number in. You really are better off connecting these things with a sort of in series, on a main switch in series, than trying to hang them off in parallel, because the short distance between those connection points is tricky to achieve. So everything's in, we're ready to power back on and to test our charge point outside. Right, we're powered up and ready to test. Now there's some settings to test in here. We've got this rotary switch set to the 25 amp option. You can see it goes up to 32 amp. We're running off a 32 amp breaker, so we're going to run the charger at 25 amps. Ordinarily we'd put this in on a 6mm cable 40 amp breaker and set it to 32 amps. Earth rod came in quite high. The RA was about 183 ohms. Fucking hell, 207. That's no good, is it? So that goes to show we are going to have to put in a secondary earth rod here. What a pain in the arse. Still, that doesn't stop us from checking everything else out here today. And the next thing we're going to check out is the RCD, which I'm going to, because we put in a type A here, I'm going to change the tester from an AC to, where is it? A type A. Same focus. Anyway, full gamut of tests passed on the RCD. Highest trip time there is 16.8 and 1 times, well within specification, but we have tested that specifically as a type A. Lovely stuff. Oh, I didn't write all that down. It's a good job I've got it on camera, isn't it? So the power's off to this at the moment. We're now going to fit it together and then do our final tests using the Doody tester. You what?
Big green light and now flashing green and amber light. Oh, 2 green lights. Lovely. Little light show on it. There we go. 2 screwdriver sizes in.
When it comes to testing this son of a bitch, we do have our EV charge check here, which is an expensive bit of kit for what it does. And what it does is it gives us our 3 lights here to indicate whether we've cocked up on connecting it up in terms of polarity. It also has the communications gear in here to tell the charge point, or to fool the charge point into thinking that a electric vehicle has been connected to it, because otherwise nothing is sprouting out of the end of here until something tells the charge point to start charging. Now that's not going to connect to there, but fortunately it does come with an adapter, so I can plug that in. And if I switch it on, we can see that the Tesla up here is now showing that it's charging by its green light, and it's very difficult to see this, but there are 3 very faint neon lights here which are all on, which indicates it's a pass in terms of polarity. The other function of this thing is to act as a presentation converter to allow us to connect our standard test equipment to it, so that we can perform an earth fault loop impedance test, an RCD test, and that sort of thing. The only thing is we can't perform an earth fault loop impedance test over this particular charge point because it has its own built-in earth fault protection. So if we try it, even on the RCD setting, excuse me, it's not going to give us a number. It's because this thing, the Tesla charger itself, is going to go, oh, there's an earth fault, and it's going to go into protective mode, which will isolate the supply until such time as we turn this off and turn it back on again to reinitialize connection. Which is why we had to take an earth fault loop impedance reading with the cover off. That's just a curious thing about the Tesla wall charger, I think, because if we plug it into something like a Rolex or a Pod Point or something else, we do get an earth fault reading from that. In fact, I'll do that when I get home on my Pod Point, just to prove that. So we can't take a ZS reading from here. We can do things like testing the RCD though, but again, we've already done that, so there's probably not much point in doing that from here. Oh, I nearly finished at last, all done apart from the paperwork. So I've labelled up the fuse for the intruder alarm. I like to say what these things do and what their fuse rating should be. Come across an awful lot of fuse points on site that aren't labelled up, which isn't terribly clever, of course, because then you have to figure out what on earth they're supposed to be doing. The old Brother label printer sure comes in handy for that. And that larger box, that dual Patras box, has now been blanked off there to allow us to once again get to the armoured cable connections should you ever need to. There's nothing in there to get to particularly though, or nothing you should need to get to. A couple of other improvements: the red sticky tape that was covering over the spareways and that board, I've now got proper blanks fitted. There's an RCD label on there. Oh, it's an up-to-date one as well, 6 monthly rather than quarterly. So that was missing before. And of course I've got my installer's label. The boards have all been labelled, given designations. I've got my installer's label up there, which says the data last inspection, gives the details of the installer and this certificate number. A couple of other quick things to mention before I disappear from this site. First of all, I'll put a label on the board to say that the EV circuit is TT and is not to be connected to the PME system. Obviously we've got to put some kind of indication. There's also a label on the box outside. Also notice, before I get slated in the comments about, to notice the difference between the breakers here. We've got the 2 devices here which aren't branded as Luden. They're actually branded as Luden control gear, which is a different range. It often gets used for things like the Denman's curve boards and that sort of stuff. And people might be thinking, oh, well, you should be putting Luden kit or Luden branded kit in a Luden branded board. If I show you the Type A RCD from Luden next to the control gear one, hopefully you can see there is absolutely No difference at all, other than the branding. And I've checked with Luden Technical Support, who say that yes, it is just a rebadge, and we can use Luden control gear equipment in a Luden board. In fact, I specifically mentioned that we'd put in the SRG1 VCU RM board for this project, and they changed out the main switch and added a breaker, and they were saying, yeah, that's fine, it's okay to use the control gear kit for this purpose. Well, that was a exciting installation, wasn't it, Nige?
It was.
I suppose some people might wonder why we did it that way, and perhaps maybe they think we made a bit of a meal of that because we perhaps made it more complicated than it needed to be. We didn't need to add surge protection, but seeing as we had to put a secondary board in, we may as well put one in that's got an SPD in it. And I was speaking to the homeowner, and he was saying that if it had got in a company who installs these things, they tend to do it in, oh shit, we should have gone the other way, it's a fucking nightmare getting out of here. If they tend to do it in the most quickest, basic way possible, which would have meant that they would have put a little consumer unit around where the meter box is, and then run an armoured cable, which would have been about 30 metres long, all the way around the outside of the house to the point of the installation, and it just would have looked a bit shit, really, wouldn't it? Fucking hell, look at this. And go where? There's just no break in it, is there?
It's that time of day.
This van driver will let me out, I know, won't he? Look at that, it's just a stream of shite coming from the left. So, so yeah, it's and also he was saying that he'd spoken to some of their installers, and they said, "Oh, we won't use your armoured cables. We have to put in our own." Well, there was nothing wrong with that armoured cable, and the fact that it wasn't ideal size for the job. But you know, if you set the thing to, if you limit the thing at 25 amps, then you're not going to get the fastest charge out of it, but it'll do the biz. And the only way to have bettered that would have been to pull in a new cable, but there was no way of doing that through the fabric of the building without knocking dirty great holes in it. And he already had said that he didn't want an armoured cable snaking all the way around the outside of his house to the rear where the meter box was. And besides which, I'm not sure that there was any room in the meter box to accommodate another little enclosure, was there, Nige? You saw in there you had your isolator in there, but I don't think there was anything you can put a...
No.
There's no way you're going to get a small...
Quite tight.
So thank goodness that's over, because that was a longer job than we anticipated it to be. Would we do another one, Nige?
Oh,
I don't know, we've got that fucking charge jet thing, it's got to pay for itself. Right. Onwards and upwards.
Let's fucks get off there.
And off to the next one.
Fucking traffic.
Because I can't demo the charge check on the Tesla charger, I'm going to demonstrate it using my own PodPoint charger. So if we plug that in. There we go. And again, at the moment the PodPoint has a white light on it. If I press this button here, we get 3 red lights on there showing that polarity is okay. I don't know if you can see that, but the PodPoint now has a green light to indicate it's got it thinks it's talking to a car. And this allows me to connect my metrol and perform a ZS test. There we go, 34.3. It's got it as a fail, of course, because I've got this set as a B6, but we're actually testing the resistance of the earth spike, so 34.3 is pretty good for the TT spike that I've got down here. Don't panic, folks, that wasn't a real explosion at the end there. That was just one more of my camera trick special effects to end the video with. So I'm in one piece, and I shall see you on the next video. Thanks for watching.